Yeah. Question. State the unit and dimension of the following quantity. State the unit and dimension of the following quantities. I. Coefficients of viscosity. IR. Modulus of elasticity. III. Angular momentum. IV. Wavelengths. V. Frequency. VI. Moment of inertia. That's moment of inertia. That's what we say we should do here. Moment of inertia. Solution. Without wasting time. Solution. Coefficients of viscosity, which you represent with this symbol. This symbol stands for what? Coefficients of viscosity. And is given as what? Frictional force over area times velocity gradient. We say frictional force over area times velocity gradient. Where velocity gradient is equal to what? Change in velocity, which is final velocity minus initial velocity over what? Height. Look at the heights. Are you saying that? That's what we call velocity gradient. V2 minus V1 over what? Height. And this means change in velocity, which I write change in velocity over what? Height. And what's this? This can be written as what? Change in velocity divided by what? H. And what's the H? Height. And this gives me change in velocity is meter per second. That's the velocity is meter per second divided by what? H, which is the height, is measured in what? Meter. Have you seen it? Meter per second, which is change in velocity, divided by what? Meter, which is the height. Coming over here, can you come over here? Can you come over here? We said meter per second divided by what? Meter over 1. Then multiplication apply. This man will come over and this one will come down. We have meter per second times 1 over meter. And I will have this meter. Can you follow me now? This meter will cancel this meter. Are you following? This meter will cancel this meter. I will have 1 over what? Seconds. And 1 over seconds, which you call 1 over seconds, is same thing as what? Seconds raised to power minus 1. Remember indices that say 1 over A is the same thing as A raised to power minus 1. This thing can be written this way. So 1 over seconds is the same thing as what? Seconds raised to power minus 1. And the dimension of velocity gradient now is a what? T raised to power minus 1. That's the dimension of velocity gradient. Is T raised to power minus what? 1. Then I come to what? Area. You remember what we say here? Area times what? Velocity gradient. Come over here. Area times velocity gradient. I have gotten velocity gradient, which is dimension is what? T raised to power minus 1. Let's go to area. And I say area equals to what? Meter times meter, which gives meter square. That's what gives me area. And meter square dimension is what? Capital L square. Are you following now? I said what? Meter times meter give me what? Area. Area is what? Length times breadth. Area is length times breadth. Remember? And what is the breadth? Breadth is length. What's the length? Length is length. And breadth is length. And breadth is measured in meter. And length is measured in meter. As we said earlier, that breadth, height, diameter, radius, depth, and what? Width. They are all measured in what? Meter. Distance are measured in meter. So length times breadth, which is area, is meter times meter, which gives me meter square. And the dimension is what? L, capital L square. Then I've gotten the what? The dimension of what? Area. Then I've gotten this, come over here. I've gotten this, I've gotten this. Let's go for frictional force, which we call force, frictional force. And as a force, we know, is equal to mass times acceleration. Mass times acceleration, and the kilogram is the unit of mass, times acceleration, which is meter per second squared. And the same thing as equals to what? 1 kilogram over 1 times meter per second squared. When you times this and times this, give me kilogram meter per second squared, which I can write kilogram meter per second squared this way. And this dimension is what? Capital M for what? Kilogram. Capital L for what? Meter. Capital what? T minus 2 for what? Second squared. Then we will not come here. We will not come back to say our what? What we call what? Coefficients of viscosity. This man stands for coefficients of viscosity equals to what? Force over what? Area times what? Velocity gradient. Then equals to, I have gotten the dimension of what? Force, look at it. And the dimension of what? Area, which is what? L squared, times the dimension of velocity gradient, which is what? T raised to power minus 1. And I begin to pieces it. Yes, when I say that what? That coefficients of viscosity, which is this is force, this is what? Area, times what? Velocity gradient. I can pieces this for you to understand properly. That's what I want to do here. I pieces it. M divided by 1. And this L divided by L raised to power 2. Then this T raised to power minus 2 divided by what? T raised to power minus what? 1. If you times this, it become what? Times M times T, which is this man, will come over here like this. This one times this will give me this. Then now, since I have done it this way, I cannot say that what? This man, now you remember the indices. This is raised to power 1. You remember that this is raised to power 1. I will not say if they are dividing themselves. Are they dividing themselves? Yes. Are they the same base? Yes. Subtract their power. That's what indices say. If they are dividing themselves and they are of the same base, subtract their power. I will now have this L minus 2. That's L raised to power 1 minus what? 2. That's what I have for this place now. Coming to this place. Are they of the same base? Yes. Base T. Power doesn't concern me. Are they of the same base? Yes. Are they dividing themselves? Yes. Subtract their power. I would answer T raised to power minus 2 minus what? Minus, this is subtract their power, minus into minus what? 1. That's what I have here. Minus 2 into minus what? 1. And this will now give me, this is M divided by 1 will give me M times, look at the times, this man now has given me 1 minus what? 2 will give me minus 1, and times minus 2 minus 1 will give me plus what? 1, and this minus 2 plus 1 will give me minus 1, and my dimension now, my dimension for what? The coefficients of viscosity index. Have you seen my dimension for viscosity, coefficients of viscosity? Let's go to question number what? I. Modulus of elasticity. E, which is defined as what? Stress over strain. Where stress, come over here, where stress is equals to what? Force over what? Area. Stress equals to force over area. Then what is force? Come over here. Force is mass times acceleration divided by what? What is the area? Capital A. Then equals to mass times acceleration divided by area. Are you following what I'm talking about? Mass times acceleration divided by area. Then I come over here. What's the unit of mass? Kilogram. Times unit of acceleration, meter per second square. Divided by the unit of what? Meter. Unit of area. What's the unit of area? Meter square. We come over here. What's the unit of what? Mass. Kilogram. What's the unit of acceleration? Are you watching what I'm doing? Meter per second square. Then divide by what? What's the unit of area? Meter square. And this can be written as this: kilogram over 1 times meter per second square divided by meter squared over 1. I think you know. I'm writing them in fractions so that you understand them. That's what I'm doing now. Then anything divided by 1 is that thing. This divided by 1 is meter square. Then coming over here, I will now say, okay, come, let's see what we do here. Kilogram, come over here. Kilogram times meter will give me kilogram meter. 1 times second square will give me second square. Then come over here, we now say kilogram meter over second square. Divided by meter squared over 1. Are you following? Watch properly here. Pay attention so that you grab it properly. Then now, here now, this is division. Multiplication apply. Kilogram meter per second square times meter square come down and 1 come over. Multiplication what? Apply here. Then you watch it here. So in now, this time this will give me what? Kilogram meter, and this time this will give me what? Second square meter square. And this can now cancel. 1 meter here will destroy 1 meter here. Meter here is 2. Meter square, meter times meter. 1 meter will destroy it, leaving you with 1 meter here. Have you seen it? Watch here, come over here. You see the 1 meter here. You've seen here. Do you want me right? So can you watch here? That's 1 meter. Then this can be written as what? Kilogram per meter per what? Second square. Kilogram per meter per second square. We have done this before, and this will give me a dimension of what? Meter, which is capital, kilogram will give me capital M, and the dimension of what? Meter is capital L, dimension of what? Seconds is capital T raised to the power minus 2. Then now, I have finished with stress. I come to strain. I have finished with stress. What's the what? Dimension of stress? Look at it. Look at dimension of stress. We have already gotten it over here. Which is dimension of stress is same thing as dimension of pressure. I think you are watching it. Dimension of stress is same thing as dimension of what? Pressure. Because we say the stress is what? Force over area. Why pressure is what? Force over area. We now see that what? This dimension of what? Stress is same thing as dimension of what? Pressure. And the drive unit of what? Stress is same thing as the drive unit of what? Pressure. We now come to strain. Strain is equal to what? Extension over what? Original length. Extension over original length. What's the extension? Extension is the what? Distance or length, which you measure the meter. What's the original length? It's meter. It's measured in meter. When I say meter, meter will cancel meter, will give me what? 1. So the dimension now, that's why we say that what? Strain is a dimensionless. What does it mean? This is a dimensionless what? Quantity. Strain is a dimensionless quantity. That's the reason why we got it to be 1. Whenever you find a dimension of a what? A quantity, and you find it to be 1, or find means what? Is a dimensionless. So note it now. Dimensionless quantity is what? 1. Its dimension is always what? 1. Any quantity that has a dimension being 1 means that it's a dimensionless what? Quantity. Can we substitute into our main equation? Therefore, modulus of elasticity E equals to stress over what? Strain, as we said, which is stress divided by strain, and we have gotten the stress to be what? Kilogram per second square per meter divided by what? 1. That's what I said. What's the strain? Is 1. That's what you said, divided by 1. The stress is what? Kilogram per second square per meter divided by 1, which is what? 1 is what? Strain. Then coming over here, I have what? Kilogram per second square per meter times 1 over 1. And that leaves me with what? Kilogram per meter square per second square per meter. Then this man can be written as what? Kilogram per meter per second square. Kilogram per meter per second square. Therefore, the dimension, which is dimension of kilogram, is the what? Mass is what? Capital M. Dimension of length is capital L. Dimension of seconds is capital what? Minus what? 2. That's capital T raised to the power minus 2. This one capital L raised to the power minus 1. And this is the dimension of what? Young modulus. That's the modulus of elasticity. You remember that this is what also called Young modulus, so that you will not be confused when we say derive what? The dimension of Young modulus. This is what we call Young modulus, or modulus of what? Elasticity. That's it. Let's go to question number what? 3, which is angular momentum. Angular momentum, which is represented with P. Angular momentum represented with P, and is equals to linear momentum, which is what? MV. What is linear momentum? Mass times velocity. Then linear momentum times radius. What's the radius? R. That's give me what? Angular momentum. Angular momentum equals to linear momentum times radius of the circular part. Because immediately you say angular means moving in a circular part. Angular means what? Moving in a circular part. He become linear momentum times the radius of the circular part in which the object is moving on. Then when I say of the circular what? Part, that was the radius times radius of the what? Circular part taken by the what? Object in circular motion. We said linear momentum times angular momentum equals to linear momentum times radius of the circular what? Part taken by the what? Object in the circular motion. That's our what? Angular momentum. Now we now say that is P for angular momentum equals to what? Mass times what? V, which is what? Linear momentum, times what? R, which is the radius of the circular part, which is the object is running on. Then now look over here. What's the unit of mass? Kilogram. times what? Unit of velocity, meter per second. So I'm basing it now. Unit of mass, kilogram, times unit of velocity, meter per second, times the unit of radius. Radius, the unit of radius is what? Meter. Radius is length, which is what? Meter. Then now, opening the bracket, this will times m, giving me kilogram m. Look at it, kilogram m. This 1 over 1 will times this will give me what? Seconds. Which this now inside this bracket give me what? Kilogram meter per second times m. Look at the m. Because this time this will give me kilogram what? Meter. Then over what? Seconds. Times meter. Then coming over here. Meter times meter over there will give me kilogram meter square. Meter times meter here will give me what? Kilogram meter square over what? Seconds. And this can be written as what? Kilogram meter square per what? Seconds. Then dimension of this become what? Meter for what? Kilogram. Kilogram, dimension of kilogram is capital M. Dimension of what? Meter is capital L. Dimension of T is capital. Dimension of what? Seconds is capital T. Raised to power what? Raised to power 1, not raised to power 2. That's raised to power what? 1. Then when I say that this become what? Dimension of what? Kilogram is what? Capital M. Dimension of meter, capital R squared. Then dimension of what? Seconds is capital T raised to power minus 1. That's my answer, which is dimension of what? Angular momentum. Look at the dimension of what? Angular momentum. We now go to what? Question number what? IV, which is what? Wavelength. Then I say wavelength, which is given as what? Velocity, speed of light over what? Frequency. You remember that we know that what? That lambda is equals to what? F times what? We know that speed of light, look at it, we know that speed of light is equals to what? Lambda times what? Frequency. Therefore, lambda is the what? Is called what? Wavelength. Making the lambda subject of formula, I have the lambda equals to what? V over what? F. That means the velocity, which is speed of wave, speed of light in air over what? Frequency. Then when I come to say the length, wavelength is equals to speed of light in the what? Air over what? Frequency. Where V, look at it, where V is the velocity of light in air, comma, and we now have that V is velocity, which is meter per seconds. Are you getting what I'm saying now? V, which is what? Meter per seconds. And it can be written this way, meter per second, and dimension is what? Capital L for meter and capital T raised to power minus 1 for what? Seconds. That dimension of what? The velocity here. And then come to what? Dimension of frequency. What's the frequency? Frequency is equals to what? 1 over period. Frequency is equals to 1 over period. And what's the unit of period? The unit of period is seconds. That means 1 over seconds, which means what? Period. Which means what? Frequency. 1 over seconds is what? Frequency, which is unit of what? Seconds is what? Unit of what? Period is what? Seconds, I mean to say. Unit of period is seconds, and this is 1. Means 1 over seconds. Give me what? Seconds raised to power minus 1. And the frequency now, the dimension of frequency is capital what? L raised to power what? R raised to power 1. Capital L raised to power 1. Therefore, and I say therefore, wavelength is equals to what? Velocity over what? Frequency, which is velocity divided by frequency, and velocity is meter per second, and the what? Frequency is 1 over what? Seconds, and this can be what? Invert and multiplication apply. That give me this, and this will cancel this. Are you get what I'm saying now? Leaving me with what? Only the meter, and we now say the dimension of wavelength is what? Meter. The dimension of wavelength is what? Meter. The dimension of wavelength is what? Meter. And we are capital L, I mean to say the dimension of wavelength is capital what? L. And the what? The unit of wavelength is meter, and the dimension is what? Capital L. Let's go to the last question, which is what? Moment of what? Inertia. VR. Moment of inertia. What is moment of inertia? Moment of inertia, which you represent with capital I, equals to mass times what? Radius raised to power what? 2. Mass times what? Radius raised to power 2. That's the definition of moment of what? Inertia. That's the formula. And that's a where M is what? Mass, which is in kilogram, and the what? R raised to power 2 means what? Radius raised to power what? 2. And what's the unit of radius? Meter. Then the meter raised to power what? 2, which we call meter squared. Then we now say moment of inertia equals to what? Kilogram times what? Radius raised to power what? 2 will be given as what? Mass times radius raised to power 2 will be given as what? Kilogram times what? Meter squared. And what's the dimension of kilogram? Capital M. Dimension of what? Meter, capital what? L squared. And this is the dimension of what? Moment of what? Inertia. That's the dimension of moment of inertia. Please, if you have not subscribed into this channel, try to subscribe for updates of other questions and answer. Because what we are entering now is in question and answer. Your past question and answer is what will be the next class, which is class 5. In our class 5 is where we are going to deal with your past question in past question in this mechanism and answer. So if you have not subscribed so that whenever we post this, you will get a notice of it and go through it. Thank you for subscribing. Thank you for sharing it to your friends. Thank you for commenting. See you in the class 5.